How hard is it to repair a sewer pipe buried 12 meters underground? The workspace is dark and cramped, leaving no room for large machinery. Pungent fumes and hidden hazards inside the pipes make the repair extremely challenging. As pipes age, ruptures, collapses and blockages become increasingly common. Routine high-pressure cleaning and pipe jacking are only temporary solutions. To tackle these problems, steel sleeves are used as liners to withstand long-term corrosion from sewage. We adopt the trenchless UV curing repair technology. Its cost often runs into hundreds of thousands, earning it the nickname, laying a golden pipeline underground. Let's witness how a beam of light revives a city's lifeline. At 8 a.m., construction workers gather for the pre-shift meeting. Safety officers deliver safety and technical briefings, going over regulations for confined space operations and emergency rescue procedures again and again. Road closure is the first line of safety defense, a mandatory pre-work measure. It protects pedestrians and vehicles, and builds a solid safety barrier for the crew. Manhole covers are lifted, and a strong stench surges out. Toxic and harmful gases accumulated over years. Workers immediately turn on the forced ventilation system. They lower orange ventilation hoses into the manholes, secure the hoses to blowers with cable ties, pump in fresh air and expel hazardous gas. After ventilation, gas detectors are used to recheck the air quality and guarantee on-site safety. Next comes the suction truck. Desilting is the prerequisite for UV curing repair. Even a tiny amount of residual sludge can ruin the entire project. Powerful vacuum suction removes stagnant water, sludge and debris from deep underground. Once the water is drained, the pipes go through high-pressure washing. Sludge and oil residue on pipe walls would form an isolation layer, preventing the repair material from bonding firmly to steel sleeves and shortening the pipe's service life. After repeated flushing, the suction truck cleans up all washed-out sludge to ensure smooth, follow-up work. Workers then inspect the pipe interior with high-definition cameras, making sure no loose soil or attachments remain, meeting all basic requirements for UV curing. The core equipment for this underground project is the UV curing repair vehicle, integrating advanced materials, machinery and automation. It has completely revolutionized the traditional method of digging up roads for pipe maintenance, enabling highly efficient repair of damaged underground pipelines. Workers head out to transport repair materials. The liner hoses are prefabricated in factories and placed on custom wooden boards during transit to avoid damage. This special UV curing liner hose is no ordinary plastic sheet. It is composed of 5 functional layers, each directly determining the overall repair quality. After loading, the crew returns to the worksite to start the next step, threading the traction rope. One end of the rope is fastened to an inspection robot, which is lowered into the manhole. Guided by staff, the robot carries the rope through the entire pipeline and exits from the opposite manhole. This thin rope acts as the lifeline for laying repair materials. Pulleys are installed at the manhole bottom to change the direction of pulling force, making it easier and smoother to draw materials through the pipe. Since workers need to enter the confined space, safety measures are upgraded once again. The pipes are ventilated and gas tested a second time. Workers put on protective suits and waterproof overalls to keep sewage and sludge off their skin. Safety harnesses are worn to prevent falls, with ground crew holding the lines at all times. Most importantly, standard gas masks are mandatory for respiratory protection. After passing the gas check, another safety briefing is conducted. Everything is ready, and workers descend into the manhole to fix the pulleys firmly in place. Now it's time to feed the liner hose. The top of the material is folded, wrapped with protective film and tightly secured with cable ties. The pre-threaded traction rope is fastened to the front end. The rest of the hose is folded properly to reduce contact with the pipe wall and lower pulling resistance. The hose must stay straight without twisting or kinking. Workers feed the material from one manhole and pull it from the other at a steady speed, until the entire pipe is lined. Excess material is cut off away from direct sunlight. Sunlight would cure the resin prematurely and render the whole hose useless. The pre-routed lamp rope is pulled out and tied to a separate rope for later use. Curing end seals are installed next. They tightly seal both ends of the liner hose, creating a fully enclosed chamber, and are fastened with cable ties to prevent detachment. The remaining hose is lowered into the manhole, leaving proper lengths at both ends. Workers re-enter the manhole to remove temporary cable ties and install guide wheels for the UV lamp array, which protect the liner film from scratches. The equipment is debugged and the lamp array preheated. All UV lamps are lit one by one to confirm normal operation. Air ducts are connected to inflate the liner for the first time. The lamp rope is untied and firmly fixed to the UV lamp array. The lamp array is gently lowered into the hose, followed by installing and fastening the end seals again. A second inflation is performed to press the liner tightly against the inner pipe wall. The lamp array is slowly pulled all the way through the pipeline. Then the UV lamps are turned on to start curing, a process that lasts 1 to 2 hours. The crew takes a short break during this period. Once curing is complete, the final work begins. End seals are removed. An excess liner material is neatly cut off with a cutter. The cut samples are kept for inspection. The cooled lamp array is carefully pulled out of the pipe. Extra material at both ends is trimmed off. Sealant is applied to the gaps between pipe sections to stop sewage corrosion and extend service life. Work at this manhole is finished. The crew moves to the other end to repeat the same procedures for trimming and gap sealing. The inner protective film is removed, and the inspection robot Ray enters for a full post-repair check. Footage from the robot's high-definition camera shows the new liner has a smooth surface with no scratches, dents, bulges, air bubbles or wrinkles, fully complying with industry standards. After confirming the pipe is clear of foreign objects and blockages, this trenchless UV curing pipe repair project is successfully completed.